This program was prepared by the AAR Damage Prevention and Loading Services Group. DPLS maintains the rules and standards for freight loading and securement for boxcars, intermodal trailers and containers, multi-level rail cars, and open-top shipments. In this presentation, we'll address two of the most basic rules for boxcar shipping: vertical center of gravity and crosswise weight distribution. Mandatory rules for boxcar shipping are found in AAR's Circular 42, General Rules Governing the Loading of Carload Shipments of Commodities in Closed Cars. We'll start with Rule 7. Center of gravity, or more accurately, vertical center of gravity, and sometimes referred to as the 98-inch rule. Cars exceeding plate C in height could result in a high vertical center of gravity, so calculating it is required. Circular 42 provides the equation by which the shipper can make this calculation, and also an example. The example looks straightforward enough, but let's see what happens if this load is of multiple heights. And to make the calculation more precise, we include a spring deflection table to account for the car floor height reduction when it's loaded. Our example is one that's fairly common in the roll paper industry: a boxcar load of rolls that steps down from 3 layers to 2 layers in the doorway. And the note reads, when loads consist of multiple sections or units having different unit heights and weights, each section or unit must be taken separately when calculating CG of the load. So here's what it looks like in 3 groups of rolls. The first group is all the rolls loaded in 3 layers. The second group consists of all the blocking rolls, or rolls that are loaded on risers. And the third group is all the rolls that are floor loaded, the 2-layer stacks. First, we need to calculate item A, the car floor height, by subtracting the spring deflection from the floor height. The car floor height can be either measured from the top of the rail or looked up in UMLR, which is the railroad's Universal Machine Language Equipment Register, available from RailInc. Item B, the railcar CG, is also in UMLR or available from the car owner. It may also be stenciled on the side of the railcar. Remember that C is the center of gravity of the load, but since we have 3 groups of rolls in our load, we need to calculate 3 separate CGs. And the same for item D, which is no more than A plus C. E we know is the light weight of the car, which is also stenciled on the side of the car and also in UMLR. And lastly, we need to calculate the weight of each of the 3 groups of rolls for item F. Now our rather simple, straightforward equation earlier has blossomed into the one above to account for the 3 different groups of rolls. Making the substitutions, we calculate this load has a combined vertical center of gravity of 97.8 inches and satisfies the 98-inch rule. Now let's look at lateral or crosswise weight distribution in boxcars. Rule 4 addresses distribution of weight crosswise in car and is generally known as the 18-inch rule. Recently, a modification to this rule was approved. Rule 4C states, under certain circumstances, unfilled crosswise void space may exceed 18 inches when the cumulative lateral load imbalance does not exceed plus or minus 8%. Commodities prone to tipping or fragile commodities do not qualify for this exception. The total combined lateral imbalance may not be less than 0.42 for the left side of the boxcar or 0.58 for the right side of the car. Left and right sides of the car may be reversed. This rule generally applies to smaller units of items such as pulp bales. This may look and sound complicated, but we've included an example in the rule to explain the concept. Basically, we need to solve for W sub R and W sub L as ratios of the total load weight, which we've defined on the top line as 1.0. So we don't even need to know the weight of the load, just the loading pattern and the amount of crosswise void in each stack. And the example presented in Circular 42 is of pulp bales. The load is pulp bales loaded in a 60-foot 9-inch interior length by 9-foot 6-inch interior width boxcar. That width 9-foot 6 also equals 114 inches. The bales loaded are 36.75 inches wide, loaded 3 across for 18 stacks, and we'll call this group A, and 2 across for 6 stacks, which we'll call group B, for a total of 24 stacks. Any remaining lengthwise space is filled in the doorway with airbags. As you can see in the load plan at the bottom of the screen, there are a total of 6 stacks where the crosswise space exceeds 18 inches. However, there are also 24 stacks that only have 4 inches of crosswise space. The 18-inch rule was designed to prevent boxcar from rolling over from a lateral weight imbalance, assuming that the entire load shifted to one sidewall, leaving the entire remaining unfilled lengthwise space at the opposite sidewall. Here's what these stacks look like from the end. Group A has 3 stacks across, while Group B has only 2 stacks across. And here's what we know. The inside width of the rail car, the calculated variables A and B, which represent the ratio of the load at each crosswise space, and the actual crosswise space for both groups. Variables A and B are key, as they define the amount of the load in each crosswise grouping. Then we simply insert these numbers into the equations and solve for W sub R and W sub L. And in this case, the right side of the boxcar is less than 0.58, and the right side of the boxcar is less than 0.58, and the left side of the boxcar is more than 0.42. So this load example has a cumulative lateral load imbalance of less than 18 inches and meets the requirements of Rule 4C, Parent 4. Please direct any questions you may have on this presentation to dpls@aar.com. Thank you.